Okay, this is a quick walkthrough of assignment 8. We're going to use our single responsibility principles data from chapter 5, which looks at currency trading application, and do a number of things to it. We're going to add a database to it, add a code map to it, and then add some unit tests to it. The first thing we have to walk through is this. I'm going to walk you through this because it's not the easiest thing to do, and it's hard for me to create this database and send it to you also. So we're going to just create a simple database. So we're going to go to Tools, Connect Database. So first I'm going to open up this assignment 8 start file. It's the same file actually that comes with your textbook, which is the single responsibility principle after refactoring for clarity is what it's called. Okay, we open it up. It has a database project, but this just has some SQL commands, and this could connect up to an SQL server. Unfortunately, it's hard for me to set up an SQL server that you can all connect to from different locations going through our firewall and stuff like that. So we're going to just create a local database instead using these SQL commands. And then this is our single responsibility project with our files in it. So we're going to go up there, Tools, Connect to Database. We're going to make sure this says Microsoft SQL Server database file. We're not connecting right to a server, but a database file on our local machine. We're going to save that file to a good location. Now this is going to store a hard path to this file, so you should try to have this in this project in a location that's not that you're not going to move recently. Now there are ways of getting around that, but for now we're not going to worry about those. By default, it should show you the project file location, and you should be able to just set the database there. So I'm just going to create the database in this location here that's in the project itself. I'm going to give it some name. We're just going to call it a trades database, and it's an MDF file. So again, I'm creating this database in a folder, and we're calling it trade database.mdf. I did trades. Let's say trade database.mdf just to be consistent. I'm going to hit open it. That file won't be there, and so now when I hit OK, it'll ask if you want to create this. This file does not exist. Do you want to create it? Say yes. And then it should go out and create that MDF file. And it should pop up the Server Explorer if it's not over here. That should pop up during this process. Okay, so I think here's my database here. I've actually created a different one for a different project, but here's the new one that shows up here. If I look in it, I see no tables. I see no stored procedure. So we're going to have to create a table and a stored procedure. So let's go back to the assignment here. So again, in the assignment, next thing is create a table. Go over to our Service Explorer, create a new table, and we're going to call it the trade table. And then, so I'm going to go here, right click on that and say add new table. It'll bring up a little SQL editing window that'll let me type in the SQL commands to create a new table, or graphically create a new table. But luckily we have SQL over here in our project that creates this table that we can use. So I'm just going to open up this under the database project, this trade.sql file, and this shows the SQL for creating the table we need. I'm just going to copy that, bring it over here and paste it into this SQL for this database. And then I'm going to hit update to save this to the database. It'll do some work, prepare things, and then I can hit update database and it'll create the table as I want. Now I can close these two fields. So I may have to refresh my database over here, but it should show my trades database. I can right click on that and say show table data. There shouldn't be any data in my table, but I can see the fields are here and ready to go. The other thing is a stored procedure. We need to create a stored procedure that we'll use. So I'm going to add a new stored procedure. Here's a generic one, but I'm going to find this insert trade stored procedure, copy that code, and go back to this new procedure that was just created to the generic one and paste in my code into that. Okay, and I'm going to update the database. update the database. I can close both of these and refresh my database. And you should see, again, the trade table and the insert trade stored procedure should be in your database. So now we can use that. So that's this creating a table, creating a stored procedure. So now we're ready to go. We can connect to that. Now in our code, we have a connection string. We have to find that. So we have to go into our, not trade records, sorry about that. Go into trade processor here, and there's a couple different routines. Read trade data, parse trades, validate trades, log message, map trades to trade record, and finally store trades. And this is the one we want. This creates a connection to the database, opens up that connection, creates a transaction, and then using that transaction, we'll send commands to that using the stored procedure. So I'm going to redo this. Here, this connection doesn't work. If you saw when we did earlier, when we run this, we get an SQL error when we try to do this open because this connection string. Connections are managed with these connection strings here. They are often a pain or a challenge to work with. So just be warned, if you do a lot of .NET work, you sometimes learn to despise connection strings. So, but we're going to get our way around that a little bit. So we're going to delete the connection string there. So it everything's almost, it'll say, new system data, SQL connection, and then for the connection string, it should say just quote, and I'll leave the semicolon there and then another quote. I'm going to add a @ sign here. That'll the connection string is going to have some backslashes in it that are going to cause problems. So I'm going to put the @ and before the quotes here, and then the connection string will go in here. Right there will be the connection string, and then we'll have a semicolon and then the closing string. So now that I've got that ready to paste in here, I'm going to go back to my trade database here. Let me move this around a little bit. I should see in my properties here the connection string here. I can copy that whole connection string. It's a long string that specifies the whole path to the database. Then I can go back to my code, and again, right between that quote and that semicolon, I'm going to paste in my connection string as I go. So it includes the full path name to the database that I'm working with here. So I've got to watch a couple things. There'll be if your code and if your path includes any spaces, it'll put double quotes in here, and that'll cause some problems because we're already in double quotes. We just have to kind of escape that. We have to put 2 double quotes in a row to handle those, since that's the @ symbol handles some of these backslashes, but we have to put 2 double quotes there, and here's the other double quote. Again, if you have a shorter path, if you just created your database at C:, or some nice simple path, you won't have to worry about that. But I have this longer path, and it's putting the quotes in there. Okay, so now that's our connection string. We should be able to run this, and it should connect to the database. Before I do that, I'm going to add, let's see, bring this back up again. Okay, I'm sorry, I got lost here. I'm going to add one more here at the end. I log messages saying that all the trades were put in there. I'm going to have another log message up at the very top right before I connect to say that I'm connecting to the database. And I don't need any parameters in that, so it should just say log message parenthesis quote info connecting to the database quote. So there I know that it's going to try to connect to the database. I can see that right away. Okay, now I can run this program and see how it works. Now if you didn't run into any problems, it should say connecting to the database and so many records added to the database. Sometimes depending on your path, some paths, especially paths with hyphens in the names, have problems, and that's what I'm getting here. I get an SQL exception still when I try to open that, and so that's because my database is in the wrong path. So if that's true, you may have to move your project to a simpler path. And again, I found places where there's hyphens in the path cause problems for this SQL connection string. So I'm going to move my path, the database, to a different location, recreate it somewhere else, and try again. Okay, so now I've got the connection running. It connects the database and processes the 4 trades. One other thing I mentioned, one other error I often see with the connection strings is when you paste them in, check, especially with longer file names, sometimes it says C:space, and there's a space in here. You don't want a space after C:, so make sure if yours got a space there, you delete that. That often clears up some of the problems with the database. But again, I just moved mine to a different location, and then I deleted it here and re-added it here, connected to the database, and just found where I moved it and reconnected to it. Okay, so now we have our database. We should be able to put trades into it. If I right click on it, show trade data, I should see the trade data. It added these 4 records to my database. Okay, so that takes care of this first part, setting this all up and running it. We're going to do one more clear up of our code. This lot size variable, we forgot to do that, and the textbook kind of ignores that. There's this public static void lot size. We're going to move that. I don't want a public static variable that's floating into my class here. So I'm going to right click on it and say show all, find all references. And it'll show where it's defined in this one spot where it's used. I'm going to copy it out of here, and I'm going to go where it's used. It's just used in this one method, map trade data to trade record. I'm going to add it as a variable there. It doesn't have to be private or static. In fact, it can't be private or static inside a method, so it's just going to be a float, lot size of 10,000. So I'm just going to move it there rather than having it float out here. Okay, so that takes care of this. Now I'm going to create a code map. It's sometimes with this code like this, it's hard to view it and see how it all works and flows together. So there are different ways of doing this. You can create a UML diagram, like a sequence diagram, to show how one method will call another, or a class diagram to show the different classes, although that often doesn't show how they all call each other. So either a UML sequence diagram or this. So there's actually a way we can view this code. Oops. So I'm going to go back into Trade Processor, and I can take any of these methods and right click on it and say show on code map, and it should create a code map, a little diagram of my code, and add things to it. There's a video that you can watch that shows more information about this, but I'm going to find actually the main method here that calls all the other methods. So down at the bottom here, there's the process trades. I'm going to show that on the code map. And once that's on the code map, I'm going to have it show, right click on it and show methods this calls. This calls a number of methods. And same with store trade, that calls a couple methods. So there are different ways of adding this, but we want to set this up so it shows the main methods here. Oh, parse trades is actually the one I want to show methods this calls. Okay, I can kind of zoom out here or in, and so it should show that process trades calls read trade data, that calls parse trades, and that calls store trade. So I can kind of move these things around to get a better view of this, and then log messages kind of sits off the side. There are externals here. I'm just going to delete that. I don't really care about the externals. Okay, now I'm going to add a couple other things. I'm going to add in, besides the that, I'm going to add in the main program, this main, add that to the code map and show here, and also add the trade records to the code map. And again, I can kind of move these around to get this a little better organized or whatever, but it should show the in single responsibility principal namespace, I've got program app main that calls process trades. Process trades calls these methods. I'm going to just again reorganize how they're laid out here. This calls read trade data, parse trades, and then store trades. Parse trades calls these routines, and then both store trades and validate trades to call my little log message. And a number of these use this trade record. Both the parse trades and the store trades use this trade record, which is in a different file. So again, this is a nice little map of this. I can get things laid out, and then I can save this map so I can look at it later. So save map as it saves it as a ggml file. I can just save it here. I'm going to save it inside my project, the single responsibility principles project, because that's where most of the code is, and save it in there. Now by default it's going to show up here, so if I close it, it's sometimes hard to find it again. So I'm going to add it back, make sure it shows up over here. So I'm going to say add an existing element. I guess this is off your screen, but it's just add existing item. And I'm going to find my code here and add it in. So I mistakenly did the wrong add, so I'll show you it again. I'm going to do add and add a new item here. Not a new item, add an existing item. Add an existing item. And then I should be able to see it here. Okay, I forgot that you can't add it here. You've got to click on your solution because it's a solution level object, code maps are. So I have to go up here at the solution level, right click on that and say add existing item. And then I should be able to go into my project and find that code. It should be a DGML file, code map. And add that in here. So it should put it up here as a solution file, so that later on when I can't find it again, it has a separate folder for those the solution items up here and the code maps up there. And that, since it's a solution level, that's why I have to right click on the solution to add it. I can't click on a project and add it. Okay, so now we've got our code map. If we want to refer to that, we can when we're trying to understand how this works. And let's go back and do the next stage. So the last thing I want to do is have you create a couple unit tests for this, and I'll show you one hint for setting those up, or at least maybe a couple hints. First, let's go in here. So I'm going to create some unit tests for process trades for this class. So the easiest way to do that, again, we couldn't go up here and create a test and set things up, but the easiest way is to go into process trades, highlight the class name, and then just say create unit tests. All this stuff you can basically leave the same as far as naming and that sort of stuff. Generally their defaults aren't bad. So it should create a single responsibility principal test area here. And one of the tests, the main test it'll have is a trade processing tests class as we look over here. So there's a default test here. Let's just look at that a little bit. By default, it just fails. Remember, we're going to want to set up this arrange, act, assert template here, so you might want to put that in just so you remember how that works. So every test starts with this test method flag above. You really don't need these brackets here. Sometimes when you create these, it puts those in there. You can have it either way. So you need a test message tag up here, and then the test with some name, and then again we're going to do some arrange, act, and assert here. So you might look at, so we're going to test this trade processor and how to set this up. So maybe you'd want to test out one of these methods like reading the trade data. And we can try to do that here and set that up, but we're going to run into some problems. So just watch as I try to set that up. So to call this, we're going to need an object, and I'm going to go look in the program. It creates a stream, creates a trade record. So this is in the main program, and I want to kind of duplicate that in my test plan as part of my arrangement. I'm going to create this trade stream, create a trade processor, one of these objects, and then I'm going to try to call in trade processor, call this read trade data method with the stream. I get an error here with assembly. We have to make sure we include the right system reflection for assemblies, just part of that. Now it also needs a text file, and here we have this text file. We want to maybe move that down here. The easiest way is to copy and paste it down there. You can go into the project and create your own text files. You have to make sure these text files, they have to be marked a certain way here. If you just import a text file, it'll just bring as a text resource or whatever. If you have a text file here, you have to make sure you switch it to embedded resource here. So we don't do that. So this is already marked as embedded resource. I can just copy and then paste that down here, and it'll add it down here. And I could make more copies and edit this. So I've got my text file here ready to go. But now in my tests, I do have to watch this. When I go out and grab the resource, it looks for this folder of the project and then dot and then the name of the file. So it looks in single responsibility principles. I want to do single responsibility principles tests because I'm now in this test project. I want to make sure that this project name matches this project name, and then I should be able to run this okay. So I want to set things up at my arrange task, and then for action I want to call, let's say, my read stream data and read in the 4 records, and then check here if the 4 records are added. And so I want to try to maybe call read trade data, but it says read trade is inaccessible due to protection level. Read trade data is a private method and not a public method. So I might say, well, is there some way of calling a private method and setting that up, or should I even be calling private methods from this? So maybe I can go over here and Google CSharp unit tests call private methods to see how I call a private method from a unit test. And I get a couple postings from Stack Overflow here. Let me just highlight a couple. So this first one lays out some code, tries to call private method, and that sort of stuff, and asks. And the first answer is, and he asks, should you be even doing this? Is there a way of doing this? How do you handle this? And answer is yes. Don't test private methods. The idea of a unit test is to test the unit's public API, the public method. You should not be testing private methods, and that has 172 upvotes. So that's getting up there. Here's another one, question on should you be testing private methods, and another description of this. And if you Google around, you'll find that there's lots of descriptions of why you should not be testing private methods. You should be testing public methods into a class in your unit tests. Here. Now there is a way of doing this. If you look at this thing, there is a private object class. You can create a private object, and then you can invoke the methods into that. So there is a way around this if you really need to, but it suggests strongly that we shouldn't be doing that. So let's go back here. So maybe we need to redefine our tests to be more like our program and just call the process trades method directly rather than the read trade method, and then process trades we'll call all the other methods. So this is our only public interface into this class, is the process trades thing. So that's going to limit some of our testing ability. So if we look at our code map again, basically we're not going to be testing these private methods independently here. We're just going to be calling this this one public method here, process trades, and let it call these other methods. Okay, so we're calling process trades, and then so how do we test if this succeeds? Well, one thing is if we don't get any exceptions, if it doesn't crash, that's good. But also it should add 4 records to the database. So we have a couple options here. One is right now the process trades method doesn't return anything, doesn't return the void. The store trades will print off how many trades are in the database or put in the database. But that's not returned. Stored trades is void, so that's not returned to process trades, and process trades doesn't return that to the main program. So one way of changing this is we could change store trades and change process trades so they both return integers, and then return, rather than just printing off the number of trades that we made, actually return the count of the number of trades that we made here, or that we processed for this. So that's one possibility. And then when we call it here, we could be keeping that. And so that's a nice clean possibility. But technically, I don't want to be changing code just for testing. So I'm going to try a different approach here. And this should be storing, well, data in the database. Can I work with that? So now in my database, in my code map, I've got this, and store trades will be actually connecting up to a database and writing out to a database. That's not shown on this map because it's kind of an external element here. Now, maybe I could create a stub or a mock database and do that. Or maybe this is going through an interface and I could mock that interface so it's not actually writing things out to the database. So that would be another possibility. I could look at, if I look at trade processor and stored trades, if this calls another method in another project to do the database stuff, I could mock that or create a mock version of that, or uses an interface, but it doesn't. It actually just writes directly to the database. So I'm kind of stuck. I can't mock or change out this because it's not in another element. It's within this. So I'm going to maybe inside here, I'll maybe count how many records are in the database and do that. So let's look at some code for counting how many records are in a database. So let's look how we might create a command to count the records. And again, this gets a little bit more into the database stuff, but also shows you how you might, if you didn't know how to do this, how you might locate this. So I see in store trades, this is how we set up a connection to the database, and we open that connection and we do some transactions. So I see we use this SQL connection database. So I might want to, I probably want to do the same stuff, create the connection, open it up, but then I want to do something different here. So and maybe I can turn to Google here, and I just Google CSharp SQL connection because that's what was used, and I want to just count the rows, and I get a couple hits here. Most of them are from Stack Overflow, a programmer's favorite website. So here's just a quick question, and so here's again using a connection, using SQL command, open the command, and count the records using this execute scalar. So that's one example, and they had the count up here. Here's another example. This doesn't tell you about the connection or whatever, but just how to do part of it. And here's another example. Again, we are creating a command, opening the connection, and I see that and do that. So I can take some of this code, try to understand a little bit, and see the similarities, and hopefully bring some of that code over. I'm just going to copy this code over and see if we can model that a little bit. So then in my test case, I'm going to create a little method to count the database records. I pasted in the first part of this where I created a connection and opened it up here, and then I pasted this other code in here. So now I'm going to select count from trade, and this pulling some SQL back from database modeling. So this is how we count the number of records or rows in a database. I want to count all the records. Count all the records in the trade table. An SQL command here. Again, I have to watch. So they called their connection my connection, and my variable is just connection here. So I'm going to clear that up. SQL command is still highlighted here. So this is a little bit of a problem, and there's no easy solution. I also see data, system.data is not found here. And this is the problem, and there's no quick solution to this either. It wants to generate a new data file. And so the problem with this is that there's a dependency here that's not clear. And so we're going to clear up that dependency. I'm going to right go into my test file, references, and right-click Add References. And by default it shows the solution stuff, but above that are the assemblies, and inside assemblies are the different system dependencies, and by default system is the only one checked. But whenever you would work with databases, there's system.data, and we are going to want that dependency in place. So I'm going to click on that also. Both of these. And again, if you were to create a database project where that would be automatically included, but since this is a test case, it wasn't. So now if I click on that and wait a sec, it should find this data here should go away. SQL command is still not quite finding here, but now I can right click and it says using system data SQL client. So I'll add that using up to the top. It can now find that since I included this system.data reference here. Okay, so this is my method. I'm using this connection. I open the connection. Here's my query. I send that query to the connection. I'm opening the connection twice, I think. I'm then doing count. I'm using my command here and executing a scalar. There's different ways of running SQL commands depending on what you get back. If I'm just getting back a number, I want to use this execute scalar, and it should return something back. I have to cast it to an int and return it. Then I close the connection here. Let's wrap this up. And again, I have this count here. I want to return this count at this point. So this should count the number of records in the database. So maybe when I do my assert, rather than just always failing, I could assert. And if you remember asserts, there's an equals that we want to do the R equals. Oops. R equals. Because assert equals does something different. R equals. I'm going to check. I'm going to count the number of records in my database now. So count DB records, and that should be equal to 4. There should be 4 records in my database. Now this isn't going to quite work, but it'll be closer. Okay, so I have this simple test here that'll run. So let's try this test out. So run will run the whole the main file, so I have to go up to test and run all the tests. So here's my test. I can click on it to see some information on it. And at this point, it looks like it's connecting. There's no exceptions being thrown, and it gets down to this assert. And the expected value is 4, and the actual value, is 8, and the actual value is 4. And actually, I should be reversing. I should actually have the 4 and the count reversed, but that's okay. So there's 2 values that it's checking, and one's 8 and one's 4, and they're not equal. And that's because in my database, if I look at my Server Explorer, and look at my trade database, view that, showed tables. I've run this now, so now there are 8 records. And I could run this again, but now there are 8 records. Next time there would be 12 records added. So what I really want to do probably is when I set this up, I want to count the number of records initially. Int start count equals, and I want to do a database count. I'm going to run my results here, and then I'm going to count the number of records I have after I run my test. I have an end count here. So after I process the trades, I'll have an end count. And then I should be able to subtract the end count minus the start count. That is what should be equal to 4 if I'm adding 4 records to the database. Okay, so this is probably the heart. Oops, I did the wrong thing. I ran the file. We want to actually run the tests. Sorry about that. Wasn't thinking. Just clicking on buttons. Okay, so I want to run these tests. It should pop up the test area, test explorer here, and the test passed. Now I want you to write 5 unit tests here. Some of them are okay, a fail, so some ideas. Now this is probably the most complicated test you can get, so I wanted to walk you through that one. But a lot of them will be, again, setting up a file here that you're going to try to connect to, creating a trade processor, and then running that file, that stream through the trade processor and see what happens. So some questions you have, so what happens if there's only one record in this thing? What if if it's an empty file? What if you give it a file name here that doesn't exist? So some of these should actually generate exceptions and fail. Some of them should maybe do nothing. So again, you can write a number of tests. It's okay if your tests don't all pass. The idea is to write tests, and some of them should fail. And then later on, with test-driven design, developers go in there and fix those so that they pass. So you just have to write 5 tests for different things. And I mean, this is a nice general format for them, though this is probably the more complicated that you'll need. But write 5 tests for this. Okay, that's what you need for this project. Zip up your completed project and submit it.